70% of Earth's surface is covered in water. That is over 1,386 million cubic kilometers. However, only 3% of it is useful. This is exacerbated by the fact that 2/3 of the world's coastal population has been polluted by seawater intrusion. Due to this problem, coastal communities do not have an adequate supply of clean water despite being surrounded by water. This is why definitive action must be taken towards creating feasible, sustainable solutions before it's too late. Shock electrodialysis is a desalination method that has the ability to carry out ionic separation without requiring a high temperature or high pressure system. Of course, this technology is superior to distillation and reverse osmosis, which have expensive prices and large energy consumption and are only available on an industrial scale. On the other hand, electrocoagulation is the method of choice for reducing pollutants in water because it has an easy mechanism and does not use additional chemicals, making it more effective and environmentally friendly. In the first year of research, we carried out a preliminary experiment by designing a desalination module using a shock electrodialysis system. This module uses a semi-permeable filtration membrane and aluminum electrode, and the casing materials were thin acrylic and rubber type. However, in terms of its capability, this module is only capable of processing artificial seawater and with low ion reduction efficiency, and it has not been tested in terms of performance and result. This is certainly a negative point that has an impact on the use value of this module. So, in this year, we are trying to improve the desalination performance of shock electrodialysis module by modifying and substituting its constituent components, and also innovations in combining with electrocoagulation as the purification method to further improve water quality. We outline all of this in a research entitled SEANU, Seawater Purifying Technology, Based Shock Electrodialysis and Electrocoagulation as a Support for Marine Tourism and Sustainable Infrastructure on Gililaba Island, Madura, second year. With my partner, Raffi Raditya Risqullah, and I'm Raditya Syarifatur Riyad, we are from SMA Laboratorium UM. The following are the aims of our research. This research was conducted for 4 months from September to December 2023. The following are the research further carried out. The manufacture of the SAD module was carried out based on previous research with several modifications and with the following design reference, using transparent acrylic polymethyl methacrylic material as a casing arranged in layers with cascading material, porous material, membrane, and electrodes. The manufacturer begins with cutting the casing and module frame, making porous material and cutting the membranes, and making the buffer and street flow. Then, the experimental stage was performed using variations in membrane and electrical voltage, and the series of tests including conductivity tests and water recovery tests. Then, electrocoagulation is carried out with the following design reference. The main material is stainless steel 304, which is corrosion resistant for use with water, meanwhile, the electrode used are made from aluminum plates.
The ability of SCD desalination can be seen through conductivity test and water recovery test. The following diagram shows the low conductivity test value at 5 ampere current and 6 ampere current, and water the highest deionization value at 5 ampere current. Even so, at 4 ampere current, the ionization value has reached 98%, so it can be seen. Concluded, the 4 ampere current is very optimal splinting salt ion in the water. Furthermore, the fresh water obtained from the SCD process has with the highest water recovery value at current 2 ampere with residual product by consultation salt liquid. The following, the table physical test result, the electrocoagulation process using TLF4 and variation treatment duration. From the table can be seen the electrocoagulation process for 6 minutes produce water with very good quality with very significant gains in water color, form, initially cloudy to clear. Chemical tests were carried out on the result of using 2 types filter, including pH, temperature, and TDS value tests. From the result of 3 tests and 2 variable notion weakened different were found, thus proving that using the off-stick filter might perform natural route to produce the same filtration as commercial filter but cheaper price in easier maintenance. Cyano was also tested to perform desalination ability by conclusion reduction in the highest content seawater, namely sulfate, magnesium, and chloride, where average reduction in the 3 ions was 81%. Furthermore, from the result of turbidity and iron content test, during the 60-minute electrocorrection treatment, the low turbidity value was obtained at 1.37 MQ with reduction efficiency of 95%. Well, in iron content test, the value obtained 0.03 mg per liter. This shows the processed water meets clean water quality standard. In the test E. coli bacteria, reduction efficiency was found to be 99.30% in 60-minute electrocoagulation process.
The design of shock electrodialysis using a cation action membrane and modification of the casing component and first material of the aerator stone with the addition of silica sand has been proven to increase desalination efficiency with salt ion reduction efficiency up to 81% obtained by seawater samples using electrical variations of the 10-volt and 2 ampere SED process. This result is much better than the SED in the first year's research. The electrocoagulation process with the best results was also obtained by turbid water samples with a reduction in turbidity up to 95% through electrical variations of 12 volt and 7 ampere, so it can be seen that the two variations above are the best electrical formulation for making cyano.